Can you tell us about the engine and the change in the original design from a turboprop layout?
Yeah, certainly. So the engine is a Pratt & Whitney Canada engine. It's an open rotor stator engine. The engine will drive a significant portion of the fuel savings. The change in terms of the configuration was really about enhancing cabin comfort. So we've done two things. We've moved the engines to the back, and we've also made the aircraft 5 abreast. So it will be the only 5 abreast in the sub 100 seat market, and it will be equivalent in terms of cabin size and feel to an A220.
What's your seating?
So for North America, of course, it's 76 seats. It can do 90 seats for Europe and Asia, and there's a potential to go beyond 90 seats as well in a high density configuration.
So will it fit inside scope clause?
It will definitely fit within scope clause. It's being designed primarily to fit within scope clause of 76 seats and 86,000 pounds max takeoff weight.
A new regional jet.
A new regional jet.
Can you share anything on timeline?
Yes. Entering in service is 2033.
2033.
Yes. And the first flight will be in 2030.
Okay.
So it's let me say, a robust development plan,
Yeah, sounds like.
which is not an unrealistic path forward. Balancing also that we are using technology which is reachable. We are focusing on the best aircraft concept and not only just on a vertical technology, as a single source for the aircraft.
Yeah.
So the aircraft is an optimization on aircraft level. It's not a dogmatic approach to make a hydrogen or a hybrid or electric. It's just what is the best result from a flight physics point of view, that you have a step change in cost reduction, in fuel consumption, which is leading to it, and all this together, let me say, towards sustainability. Because if the sustainability is not meeting a realistic product, is not meeting the market, you do nothing.
Yeah, I agree. Yeah.
So this is why we like to combine this.
So you're trying to have technology that's sort of close to entering the service stage and not a lot of prototyping. But where, if you look at that, where do you think on this design here now would be the biggest technology risk still? Is that
The
dependency on
technology
Pratt & Whitney to get the engine right, or?
Yeah, I think Pratt & Whitney is working a long time on this engine technology, and we have, for the key techno bricks is the engine, is the open rotor, it's the more electric high voltage network, and for this we have until PDR of the aircraft, where you need to reach TRL 6, Technology Readiness 6. We have with this company technology roadmaps. And after PDR, which is the beginning of 2027, we have a clear path for the industrialization of the product.
Is this essentially a way for Mitsubishi to get back into the regional aircraft market after CRJ, after space jets?
So Mitsubishi the relationship is MHI-RJ is a service provider to MaeveJet, so we're helping them with the design. Our engineering services group is providing engineering services, as well as our advisory groups providing services on sales, marketing, communications, and supply chain. So we're a partner in that we're helping them. It's not a way for MHI to be in the regional jet business.
Right, so you're not going back into the building of...
That would have been my question. You would not do the manufacturing then? Or?
Well, I mean, we don't know where it will go in the future, but today our relationship is providing services to MaeveJet to ensure they get the right design in an airplane that goes into service and serves the right markets.
Who's designing the wing?
We are deciding the wing. Because the wing is one of the most important things on the aircraft. And there's only less knowledge around the world to do it.
I'm still stuck on the engine idea. How did you come to this selection?
So,
How much thrust? How much thrust are we talking?
about 40,000 pounds.
14,000 pounds.
14.
Yeah.
Okay.
So it's as Ross have mentioned before, you know, you need to have a future-proven platform. A future platform needs to be a step change in the efficiency, but also in the strategy of the platform. Why we, for example, have a 5-abreast platform, because you also can stretch it. You know, with a 4-abreast platform, you are today not engaging the market of tomorrow. For the engine, it's very clear there are two aspects. It's the aerodynamic of the aircraft and the engine itself and the propulsive element you are using. So the engine efficiency overall is the propulsive efficiency and the thermal efficiency. And the open rotor has the same propulsive efficiency. We are all proud why the turboprops use less fuel. The issue is a turboprop at Mach 0.75 is the most inefficient thing you have, because it's not done for the speed. So what you see on the A400M, you stretch this capability of a turboprop to a higher speed. The result is you grow in the diameter and you grow and have a massive part of propeller, which the integration to the airframe makes it very difficult, and also the comfort of the passenger. So the open rotor with the stator, with the squirrel vanes, stator vanes behind, is supporting to get the diameter back to something which enables a rear installation. So you have now an rear installed, let me say, propeller with stators behind, with the same efficiency like a propeller, and you combine a new advanced engine with a high thermal efficiency. So you have an increase of 15 to 18% in the propulsive efficiency, plus 10% in the thermal efficiency. Both together is a step change for a future aircraft. This is the reason we have done this.
And what do you estimate your cost per seat is going to look like? This model versus, let's say, what's available now?
We are making a working car. It's high tech, where you need to make a difference. But for example, we're making a normal metal fuselage and not in composite, because it's waste of money for a regional aircraft. So we need to focus to spend the money where it is really doing something benefit, but limited the innovation where it's no benefit. So the cost per seat will be in the ballparks like the jets today.
Not going to be lower.
It'll be low. It'll be
From an
lower,
operational point of view, but we like to get money for the aircraft, you know.
So it's metal fuselage composite wing.
So the wing, we are in the trade study still. The fuselage will be definitely metallic. Yeah.
And you say it will be same cost per seat as with the.
From
It'll
the
be
cost of the
lower
aircraft.
cost per seat than the existing aircraft.
You mean from
Right.
an operational point of view?
Yes.
Yes.
I mean, for an airline.
For airline, it's
Because that's what I'm seeing right now. There's a lot of these projects out there, right?
It's 20% less.
20% less
Yes.
per seat per
Yes.
passenger. Okay, interesting.
Because it's driven by the fuel consumption reduction, by the more electric systems, we don't have hydraulic and bleed, and it's also by the low NOxes we have and the low external noise. It's the landing fees as they start in, especially in Europe, to increase this by these factors, you know. So it's landing fees, maintenance cost, and fuel consumption.
How convinced are you by the low external noise, given it's an open rotor?
The open rotor has less noise than the propeller. Because of the smaller diameter, you can reduce a little bit more blades, you reduce the tip speed, and this squirreled recovery vanes behind are securing that the normal drill of the air behind the propeller will be straightened. This also by the higher efficiency, but also you have less turbulences behind. So it's much different. You know, in the 80s they was failing with this open rotor, because they had to have the performance on the higher speed, they have this counter-rotating concept, and it was from the performance good, but from the noise it was the opposite. It was even increasing the noise like hell. So this is why at this time they stopped open rotor. But now with this different concept of the different aerodynamic concept, it will be a future-proof and tough thing. We have also a follower, you know. Airbus is also convinced, and it's maybe good.
When do we expect to see an engine like this being test flown?
Next year. It has been just announced, by the way, yesterday, isn't it?
Didn't see.
Last question from me.
Yeah.
What's your proposed range? For you?
It's around 1,000 nautical miles.
1,000 nautical
It depends on the configuration. With 76 pucks, it's 1,400, 1,300, 1,400 exactly, I think, in the paper. With the 100 seat max high density, it's something like 950 nautical miles.
Okay.
Can you explain to us what is the role of Japan Airlines from today's announcement? What do they do in this project?
So Japan Airlines will be cooperating on the design of the aircraft to ensure that the aircraft meets the needs of an airline. You know, Martin can work with our team to design the aircraft from an OEM perspective, but there's input that you require from airlines, and you need to have a broad selection of airlines helping you design the aircraft. Japan Airlines will help with that.
You said broad selection of airlines, is it? Do you have anybody other than Japan Airlines?
There will be more.
Very soon, yes.
You're not going to end up building another Trident, so there's one market.
There won't be one market for this. We've discussed the aircraft with a number of airlines, and there is interest. Japan Airlines is the first.
Is that contingent on them ultimately being a customer, or is that
That's the objective, for sure.
I'd say that's where we'd like it to go. None of it is contingent upon that being the case. But they have the interest in the aircraft. What they see for this airplane is today their regional market is they have Embraers, ATRs, and Dash 8s fulfilling their missions. They can potentially replace all of those three types of aircraft with a single type with this aircraft. So they're interested in exploring the airplane and certainly helping Maeve in the design. Good?